Okay, so for number 5 here, SA 5, it's similar to number 7. We just did number 7, and the idea was that we had the solid ball, and when you bore through it, you get a solid bead. But in number 5 here, you have just the sphere itself, and when you bore through that with a cylinder, now again, this is a sphere of radius 10, and that's a cylinder of radius 6. So altogether, what's left when you bore through there, it's just this bit of surface. This again, if you interpret the sphere as being kind of like the surface of the Earth, then it's just the temperate zone of the surface of it. Just the surface, though. There's nothing on the inside. There never was. This is just a two-dimensional surface sphere. So there's just a two-dimensional kind of ring kind of thing there. Okay. So now let's keep in mind this is an oriented sphere. The sphere originally oriented outward. Right, so what's left over here still oriented outward. Cool? Okay. So we want to ask now, let's talk about the boundary of this surface S. Well, the boundary of a surface is a curve or a collection of curves, perhaps. And in this case, yeah, that's right. I mean, the boundary is these two curves. Well, maybe I'll just leave on this picture. We have this curve and this curve, right? And the remaining question is, what orientation is there on each of these curves? Well, we have a rule. Now you can do it with the whole, tangent vector, normal vector, vector pointing inward to the surface, right-hand rule. I find that hard, confusing. I like the side swiping, right-hand rule, spinning one. In other words, imagine your thumb pointing in the direction of that normal vector there. If your thumb's pointing that way, which way do your fingers curl around? Well, they curl around kind of like that. And how does that side swipe up against that? Well, it side swipes up against it that way. Does that make sense? Goes around that way like that. So as seen from above, you'd say that it's going to be going clockwise as seen from above on that bit of boundary curve. Is that okay? Okay. Now, this same normal vector, if you carry it down to here, again, right-hand rule, thumb in the direction of the normal vector, curl the fingers around. The fingers are going to be curling around, which you're going to want to call the same way, right? But the way that side swipes up against this bit of boundary curve, it kind of feels like the opposite way. You know what I mean? Because as seen from above, this one was going clockwise. But as seen from above, this one's going counterclockwise. And that's just because it's on the bottom of the surface instead of the top of the surface. So it just kind of looks kind of backwards. Do you see how this side swipes up against that in that way? Okay. Does that make sense? Is everything good here? Everybody happy? Any questions more about this? You look like you're about to ask a question.
So is it like conventional? If you look at from the top and bottom, they look like have opposite orientation.
Well, you said, is it conventional?
Or
typical?
Is it typical, or is it?
Let me just say that in this case it is. I mean, it'd be similar. I mean, let's suppose the problem asked you about a cylinder. Right? I mean, you can tell that it's going to be roughly the same picture, normal vector like that, right-hand rule, side swiping. It's going to be the same kind of deal. Yeah, it's going to look opposite. The fact that this was, straight sides instead of curved sides doesn't really make any difference. So, yeah, I mean, there are a lot of situations where this kind of thing happens. The problem is, so your question was a little too general, let me paraphrase your question as, does this always happen? Well, you have to give a precise definition of what do you mean by this? if you want an answer to that question. And it's hard to precisely define by what we mean by this exactly. I would suggest that what you take from this is that in this example, it works out in this way, and take them case by case. Yeah. Okay. All right.